The figure is made up of 8 identical squares, semicircles, and quadrants. Each side of the square is 5 centimeters. Find the area of the shaded part. Correct your answer to 2 decimal places. For this, being a shape question, there are usually 2 approaches. Number 1, you either shift the shapes around or you cut it up and then you shift it around. For this case, we're going to do the second case, which is we're going to shift it around. Now let's take note of this shaded part over here. Okay, so there's this over here, one quadrant, and then there is another quadrant over here. To make things simpler, imagine right now I'm going to shift this over here. This shaded part to occupy this space and this quadrant to occupy this space. Can you imagine the ending shape? Alright, you will just get a big semicircle over here whereby these two squares within it, they are unshaded. Okay, so to repeat, after I've shifted this over here and this shaded quadrant over here, what I will get is one big semicircle with these 2 squares within it, they are unshaded. Alright, so to find the area of the shaded part, all I have to do is take this entire semicircle, subtract away these 2 squares, and that will give me the answer. Hence, let me first find the area of the big semicircle. There will be half times the area of the full circle, which is pi, times the radius being over here, which is, let me write it down, 10 cm times 10 times 10. And that will give me 50 pi centimeter square. Right now, I will just do everything in terms of pi. Only at the final step, then I will compute it into the calculator and then round to 2 decimal places. If I were to compute the pi value immediately into the calculator, I will get a string of decimal places, and then I will have to bring forward that string of decimal places into all my steps. It will get quite messy, so I will just do everything in terms of pi first. Moving on, now I'm going to figure out the area of the 2 squares. So area of 2 squares, and that will be 5 times 5 times 2, or you can just find the area of this rectangle. It's the same. So I'm just going to find the area of the rectangle, 10 cm times 5 cm. That will give me 50 cm square. The last step, okay, let me draw a line down. Area of the shaded part. That will be 50 pi centimeter square minus 50 cm square. Key all this into the calculator. Remember to correct to 2 decimal places. The answer is 107.08 cm square corrected to 2 decimal place. Question 2. The figure below shows a circle inside a square of side 12 centimeters. Alright, over here. O is the center of the circle over here. What percentage of the figure is shaded? Take pi to be equal to 3.14. So we have this shape. Again, to find the shape individually, alright, to separate the shaded parts and then to find them individually or in groups, that will be quite difficult. So let's try and manipulate the shapes. One thing you can see, let's cut it up in this manner. All right, let me change this. Okay, so what if I did this? So that there is a mirror image. Now let's try and shift the shapes around. One of the most obvious way to shift it is taking this, let me shade it, probably. Okay, take this triangle over here, and where do you move it to? You move it here. Once you move it here, you will get one semicircle and this triangle. Alright, again, to find the shaded area, after you shift this here, you will cover the entire semicircle plus this triangle. Both are quite easy to find in terms of their area. So let's start. Step 1, area of the semicircle. There will be half times the pi, which is 3.14, times the radius. In this case, the radius will be 6. Alright, since this is a square, therefore, this is 6, this is also 6. 6 centimeter times 6 centimeter. And the answer here is 56.52 centimeter square. Next, we are going to find the area of this triangle over here. This triangle over here. And area of triangle is equal to half times the base, which is 6. This is the base, and then the vertical height times another 6. That will be 18 centimeter square. Moving on to the answer, percentage of the figure that is shaded. To find the percentage of the figure that is shaded, for some of y'all, if you have forgotten how to do it, maybe you can think about another way. Instead of finding what percentage of first, you can figure out what is the what fraction of. We have learned that since primary 5, isn't it? So what fraction of the figure is shaded? So what fraction of the entire thing is shaded? The fraction answer would just be the shaded area, which is 56.52 plus 18. This is the shaded area out of the entire figure. In this case, we know that it is 12 times 12, isn't it? This is a square, so the area of the square is 12 times 12. Now, this is the fraction answer. If they ask fraction of the figure that is shaded, you solve for this, and that is the final answer. However, in this case, they want the percentage answer. So we're going to convert this fraction answer, all right, this thing into percentage. And how do we convert fraction to percentage? We multiply it by 100%. Take note, when you key this whole thing into the calculator, do not type in the percentage symbol. You will treat this like any other units like meter, cm, kg, liters, etc. Okay, so you do not key units into the calculator. So we just type this divided by this, multiply by 100. So the answer is 51.75%. Question 3. The diagram below shows a quadrant. This thing is the quadrant. And a right angle triangle over here. What is the difference in area between the two shaded parts? Take pi to be equal to 3.14. First, let's analyze the figure. Are we able to find the shaded parts directly? Not really, not in this case, as far as our syllabus goes. Therefore, are we able to find the unshaded part directly? Doesn't seem obvious also. Therefore, let's think about another way to do it. One thing you must recognize is the quadrant, alright, the quadrant and the right angle triangle. What is the thing in common between them? It is this unshaded part, isn't it? Oh, maybe I shouldn't shade it to reduce the confusion. Let me highlight it instead. The only the things they have in common is this unshaded part. Okay, they share this part over here. Hence, you think about it. We shall call this unshaded part maybe part A. Okay, this is part A. This quadrant is made up of A and this. The right angle triangle is made up of the same A and this part here. What happens if I were to take the difference between the right angle triangle and the quadrant? You think about it. Will it be the same as finding the difference in these two shaded parts? Probably I will illustrate using a model. Maybe it's easier for everyone to understand. Let's start with the quadrant. Alright, what is the area of the quadrant? We know that we have A over here and the shaded portion probably is this much, I'm not sure. Okay, what about the right angle triangle? Okay, so for this, what about the triangle? For the triangle, it is made up of the same, let me change it, the same A over here. Alright, the exact same A plus this portion, isn't it? So probably I can draw it slightly differently over here. Can you see it? Now, what does the question want us to find? They want us to find the difference in the area, which means the difference between these two parts. Alright, denoted by this question mark here. So what do? Alright, you just need to take the difference between their total area. That means I'll just take the difference between the quadrant and the triangle area. Now, as of now, I'm not too sure who has a bigger area, whether it's the quadrant or the triangle. It doesn't really matter. Okay, I will just take the difference in their area and that will just give me the answer. So let's first figure out the area of the quadrant. The area of the quadrant is a quarter times pi 3.14 times the radius, which is 12 times 12. And the answer is 113.04 cm square. Next, let me find the area of the right angle triangle. Which is equal to half times the base 18 and the height 12. Which is 9 times 12, that will give you 108 cm square. So, okay, so remember my point, it doesn't really matter who has a bigger area, so my drawing could be swapped out the other way, alright? The quadrant has a bigger area, but doesn't really matter, okay? So I just need to take their difference. When I take their difference, I will be able to find the answer, which is this part, okay? So last step, difference in area between the two shaded parts. That will be 113.04 cm square minus 108 cm square. So the answer is 5.04 cm square. Question 4. The figure below shows the design of a flora. The edges, meaning the parameter, right? The edges of the rug is made up of 4 semicircles and 4 quarter circles, alright, or 4 quadrants. So 1 semicircle, 2, 3, 4 semicircles, and the 4 quadrants, 1, 2, 3, 4. So the edges, which is the parameter, okay, is made up of all this. Each of radius 14 cm. So this is, maybe I can do it here. This is 14. And what can we say about the diameter? 28. Okay. Find the area of the rug. Remember, in order to analyze it properly, we need to divide the shapes up. How do we divide it up? One way, for most of you, I hope you all can see it, is to do this. What happens if I do this, and then I'll do this? Divide them into equal squares. Now my job is much easier. I will just need to figure out how many circles are there and how many squares are there. And then I will just need to add them up. So how many circles are there? Let me shade it. I have this, and this is one circle. This and this, the second circle. And 1, 2, 3, 4. So in total, I will have 3 full circles, followed by how many square? Let me do it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I don't want to write a 10 inside here for confusion. So there are 10 small squares, 3 full circles, and 10 squares. So find the total area. Step 1, area of 3 circles, which is 3 times pi, 22 out of 7, times the radius, which is 14, times 14. Again, this gives us the area of one circle, so we need to multiply it by 3 to find 3 circles. 1848 cm square. Next, let's find out the area of the square. Area of how many squares? We have 10. 10 squares. So 10 times, what is the area of 1 square? 14 times 14. The answer is 1960 cm square. Finally, the total area of the rug that is 1848 plus 1960 3808 cm square. Okay, so to summarize, again, I want to repeat, for most of the shape questions, it's either, you see what I'm doing here, you cut it up into nicer shapes, or you shift it around. So what I did is actually shifting the quadrants and the semicircles to form one full circle, so it's easier for me to calculate. Okay? I'll see you in the next lesson.